All right, so in the second half of Unit 8 that we're going to be focusing on now, we're going to continue our work with quadratic functions, and now we're going to be looking specifically at graphing these quadratic functions. So we're going to just focus on what the graph looks like. We had a little bit of an introduction to this in the first half of the unit, but we're going to get more specifically into the graphs now in the second half of Unit 8. So our do now here wants us to compare together the two equations y equals x squared and y equals negative x squared. So in order to graph, again, you have a few options. There's an app on your phone, or if you just go online and you type in graphing calculator, you'll get the following. So if I want to graph y equals x squared, I come over here, I type in y equals x squared, and I should have my parabola here. And the second thing my do now wants me to graph is y equals negative x squared. And we'll notice that looks as such. So looking at y equals x squared, that's our graph here in purple. We notice that that's an upward facing parabola. And y equals negative x squared is also a parabola, or that U shape, but it is upside down. So just to summarize what we see here, we see that both of them are parabolas, but we have one of them that's facing up, that's this one here, y equals x squared, and we have the upside down parabola, y equals negative x squared. So you'll notice that all of our quadratic functions should look like a parabola or a U shape, but sometimes they might be right side up, sometimes they might be upside down. So to continue our work here, we're going to be in the new packet that's called Graphing Quadratic Equations. So if you haven't yet, please go print out this packet or just pull it up as a tab on your computer so that you can follow along on page 1. So at the top here, it says a quadratic function is a function that can be represented by the equation of the form f of x equals ax squared plus bx plus c. So we remember from the first half of this unit that we would call this our standard form, where a, b, and c are constants and a is not equal to 0. Notice that the greatest exponent of the variable x is 2. The most basic quadratic function is f of x equals x squared, and that's called the parent quadratic function. Now, what we mean by parent is just the original or the most basic quadratic function. So if you hear us using this phrase parent quadratic function, that means our original. Two more vocabulary to review at the bottom here. Again, we've learned this from the beginning of the unit, but that U-shaped curve that we have, we gave that the name of a parabola. And now we're going to identify a new vocabulary word called the vertex. So I want you to take a moment to read through our example here, A and B, try to fill that in and answer your think, write, pair, share questions, and then come back to check your work. Okay, so filling in our table right here, I noticed that the pattern here is that they were filling in from -3 all the way to +3. So our missing numbers in our x column were -1 and +2. And now to get our output values, our f of x or our y, we needed to take our x values and we needed to square those. And you'll notice that some of these were already done for us, but we'll fill in the rest of the table that is not yet completed. So you'll notice that here we're already given 9, -2 squared we know is 4, -1 squared we know is 1, 0 squared we notice is 0, that's already there for us. 1 squared, we'll fill that one in, that would be 1. 2 squared is 4, that's already there for us. And 3 squared would be 9. So if we go to plot these points on our graph here, we have -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And we'll go ahead and just connect those points with a nice curved shape so that it looks like a parabola. So to answer our think, write, pair, share questions, why did they choose to put these specific points? Because there are a bunch of points we could have put on our graph, so why do we think that they chose these points? And for this, I'm going to say that these points here show the vertex and points on either side. So again, I kind of introduced that word vertex down here. It said that this is called the turning point. So in our graph right here, this point right here would be our vertex, because we noticed that the points were coming down, 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 and then they started to go back up. So you'll notice in our table that this point right here is our vertex. So that's in the middle. Then I decided to just put a couple points on the left side and a couple points on the right. So when we're trying to graph in this lesson, let's always try to put our vertex right in the middle of our table so that we can have some symmetry on either side. Now to review here, our question number 2 and 3 is about domain and range. So domain, we remember, are our x values, and range we know are our y values. So if we start with domain, if I think about what x values would I be allowed to substitute here, I could put in any number that I want for x, and that would work. So the way that I write any number is negative infinity is less than or equal to x is less than or equal to positive infinity. Basically just saying any number I can substitute for x. Our range, though, is a little bit different. I notice here that the smallest y value that I have is at y equals 0, and I notice that I have no y values below that. So algebraically, how we represent that I'm not less than 0 is y is greater than or equal to 0. So again, this right here was our parent or original function. Let's take a look at our guided practice where we're going to be graphing a different equation. So now our task here is to graph y equals x squared minus 4x minus 1. Again, we'll let our calculator do the work for us here. So we'll come back to our calculator, can clear out what we have. And we're wanting to graph y equals x squared minus 4x minus 1. Now again, I notice that there are a lot of points here. If I zoom out, I notice there's a lot of different points I could choose, but we talked about this important point right here, which is our vertex. So you'll notice I've highlighted here, the middle point or the turning point of our graph is at 2, negative 5. So let's go ahead and put 2, negative 5 right in the middle of our table. So I'm going to put 2, negative 5 here. Again, because that represents our vertex. And then let's just try to put some points on either side. So we'll plot 3, 4, and 5. We'll plot 1, 0, and negative 1. Now you'll notice that we can get some more of these points right in our graph here. If you click here, they're giving us that at 0, I have negative 1. So that's another point that we can add to our table. So at 0, we have negative 1. And now for the rest of these points, you can go and use the table feature. So if you come back to where you typed in your equation here, if you hit the settings button and then you click on the table, that will give you a table of values, which will give you other values that you can add to your table. So let's go ahead and finish filling in our table and go ahead and plot our points. Okay, so first I'm going to start by plotting our vertex, and then we'll do some points on either side. Okay, we'll go ahead and connect those with a nice smooth curve. And there we have it. There's our graph for the guided practice. So now we're going to get up to our checkpoint question. Our checkpoint question is actually going to be in the Regents packet. So please go back to Unit 8. Please take the Regents packet, go to question number 27. You're being asked to graph this equation right here. And in the second part down here, they want you to identify the vertex of your graph. So please take a moment, go ahead and try this, and only come back when you're ready to check your answers. If you're not able to print out the Regents packet, please just try to sketch this on a piece of paper. Okay, so at this point you should be coming back to the video only if you're ready to go ahead and check your answers for your checkpoint. Here is what your graph should have looked like. So your graph should be an upside down parabola. Again, you can plot as many or as few points as you want. The more you plot, the more organized your graph will be. And you should have identified here your vertex of -3, 9 as your vertex. Okay, so I want you to think about how you did on this checkpoint question before you get into your independent practice. Our 3 groups are right here. So if you weren't really able to graph or identify the vertex, you weren't really sure how to use your calculator to help you, I would like you to start in the red problems. If you tried to graph, but maybe you made a couple errors or you weren't able to identify your vertex, you can start in yellow. And for green, this would be only if you could correctly draw a nice, neat graph and also identify your vertex. We'd like you to do at least one group of practice, but I would suggest you also moving to the next group. So it would be great to see our reds also doing yellow, our yellows also doing green, and our greens also getting to the extension. For everyone that's practicing, please take note that now in your Regions packet, you can now answer question number 5 in the Regions packet. So right now, please go ahead and pause your video and go spend about 10-15 minutes working on your practice, and then come back to check your answers. Okay, so at this point, you should be coming back to the video only if you're ready to check your answers. Here is numbers 1 through 4 on page 2. Feel free to pause the video to check your work. And here is numbers 5 through 8 on the bottom of page 2. Go ahead and pause the video to check your work. Okay, so in order to get your credit for this lesson, please make sure in Google Classroom you go and submit a picture of your checkpoint question as well as which independent practice problems you completed so that we can grade it and give you credit for completing this lesson. Last but not least, we're just going to start with this quick write. We can do this together. There's no exit ticket problem for this lesson. Just to review some key ideas here. Our first question is, what does the graph of a quadratic function look like? And we want to review our important vocabulary word that it looks like a parabola, which we know parabola is a fancy way for saying that it is U-shaped. You could either say that it's a regular upwards facing U or it's upside down. So all quadratic functions should look like a parabola. Our second question, what are some important points to include on your graph and also in your table of values? We definitely want to mention here the vertex. So we know the vertex is that turning point. And then we would say that you also want points on either side. So that means a couple points on the left side and a couple on the right, just so you can get an idea of what your graph should look like. Okay, so at this point, please make sure that you go and submit a picture of your checkpoint and your independent practice so you can get credit for this lesson.